Okay, we got a handful of things to do. Not hearing anything. Turn up volume. Go to the home page. At the bottom of the home page, you will see a CIQ at the bottom. This is a little bit of self-reflective stuff. Hey, Jack, how are you doing? So right there at the bottom where it says array set, do that CIQ. This is you being self-reflective about what grade you think you should get in this class, and then we will discuss that. Yeah. Let's see where that should be. Where's that going? Well, it should be on here. Let's talk through it. What do we think a rubric should be for this? Homework. Homework. Are you completing the homework? Some of you are not getting that all done. What else? How about projects? What factors of the project should we count? Effort. How am I going to judge effort?
Well, projects we like fit them together in project.
Partially, right? So completed, right? On time. Do they work? Okay. What else? Classroom. Okay. On.
Ask a question.
Okay, you ask questions.
Showing not prepared in more time.
Cool. Farther I get down on the board, the harder it is to remain prepared. Time. Yeah, the upper up here is actually. What are we forgetting in there? And I'll find the real rubric here, but those are the ones that are. Coming along. Are we forgetting anything on there? Should be why is it not here? Here's the first one. I'll let you look through this one. How much more time do we want with this?
Five, 1 minute.
Okay, give me 4. Okay, when you are done, we're gonna take a look at what I handed out to you. Actually, since only two of you actually responded, so I'm gonna do another couple minutes. Wait for a quorum here. Wait, that's it. Yep.
Final project, for the last midterm, that was the Ray deck, right?
Sorry, you're what?
For last midterm, that was,
Like the midterm grades?
yeah, like the final project.
Yep.
That was the Ray deck.
Yep. Okay, so if we take a quick look at this, we're not going to do this. I just want to give this to you sort of as an example. And what I will do is I'm gonna take the first page of it back, and then I'm gonna leave you with the rest of it to work through some of this, just to have a sense of, because this is going back to int lists, right? So this is an early example of a worksheet that is from our actual 61B class, the Berkeley class, okay? So the first one is Tucson, which should look familiar, right? The trick is your handwriting it, okay? Add digits. So this one's a little bit different. This is actually just there's another leak code here. Given a number, add its digits together to get another number. Keep doing this until the result is less than 10, and then return that value. We have 1, 2, 3, 4, 9. We add those up, we get 19. We add 1 and 9, we get 10. We add 1 and 0, we get 1. We return 1. Okay. And then we have a handful of sort of manipulations of linked lists. The box and pointer diagrams, I usually don't make you do. The question 4 is just filling in what would look like the visualizer ostensibly.
Now, forget about the what.
Box and pointer, yeah, it's just like what would a visualizer look like with its pointers and stuff like that. That's all that is. And I don't think you'll do any of those. However, the next one, reversing a linked list, you'll see questions, whatever, 5, and then the extra, whatever that is reversing a linked list non-destructively, and then reversing a linked list destructively. That's the kind of thing that you might see. So our final exam, I was trying to explain last week, is just going to be worksheet like this. Okay? Ostensibly with different questions covering the stuff that we talked about in class. They're hard, right? Some of these get pretty hard, so it's just going to be a question of like, well, what should you do? You look at a question, you're like, I really have no idea. What should you do?
Find it,
You write it.
see what, I like try to see what it wants and then see what's given. And
Yeah,
just try to come up with like, you know how like our test cases, like basically do that, but like. on paper.
Yeah. Yeah, just get down as much as you can. Like, okay, I know that I need to iterate through the whole, whatever it is, right? I'm gonna do that, right? I'm going to, if it's an int list one, you might see one sort of int list one, right? So you probably should draw some diagrams of what's happening, right? And just write down the steps of what's happening as it's happening, right? So, again, the average, I think I told you this, right? Do you all remember what the average on the midterm is at Berkeley? Like 50? It's in the 50s, maybe the low 60s, depending on the year. So they're hard, right? This is not the midterm for Berkeley, so don't worry about that. And I'm not going to give you like, if you get a 50 on it, don't worry, okay? But this is going to be a little bit, you're going to have to, apply yourself to, sort of get through as much of it as you can. Somehow.
Oh, no, I was gonna say like during recursion, I like to brought it out, I was like, you were asking like, what do we do with your stuff?
Drawing diagrams is super helpful. It's certainly if it helps you, and then as much as your diagram can help me understand what you're trying to do, that's also good. Okay?
Yeah, are we gonna get like a study guide for it, or just like review things we learned?
Yeah, I can try and pull it together, but essentially it's gonna cover most of the stuff we learned. And they're almost more like Tucson stuff, they're almost more like leak code problems than they are like, can you implement iterator? I'm not gonna ask anything like that. Right, so, or comparable, like implement comparable in your own code, that's not going to be what's happening.
So we have like the whole 2 hours.
Yeah.
How many questions?
I've got to double check, because I'm taking out the ones that aren't particularly relevant. It's not gonna take you the full 2 hours, shouldn't, I don't think it'll take the full 2 hours.
That was my question, it's not my question.
Yes. No, I'm shooting for an hour to an hour and a half of actual. That work.
Are they the ones that we have here?
What's that?
The ones that we have here?
Like these actual questions?
Yeah.
I just want different switch, you can get a lot of the rest of it. Or do you guys want to actually, you know what? Let me take the whole thing back and then I'll decide, because I just want to give you an example. And I want to give this part of this to you for homework, but I don't want to because we actually have something else working on the moment. Cool. Okay, so we need to come back to our array set iterator. And I've talked to a couple of people about this, okay? Get rid of this. So let's open up in IntelliJ, open up your array set. And the trick here, okay, and this is what I highly recommend when you're learning computer science, okay, because it's really easy to be like, oh, I now, I sort of get how to implement an iterator, okay? My 2 cents to you is go in here, take all of this code, okay, and erase it. And then rewrite it. Okay, and you can, if you want to, if you're like, hey, I'm not super comfortable on that, right? You can put it back. You can command option. We can comment it all out. Okay, and actually, I don't want to comment. Yeah, I do. Get it off your screen. Okay, and then rewrite it. Okay. So that's my 2 cents to you in terms of doing that. I think what I'd like to do is to show you how this all works together and get through the rest of the lectures that we've done with that. And then we'll go back and do this, okay? So I'm going to put this all back for a second. Anyone figure out how to make this actually work? Or let's sort of step back 2 steps. We have down here, what was the point of all this? Why do we go through iterator?
How like for each loop works.
Yeah, so essentially, yeah, so we know how a for each loop works, but now what can we do with our own classes?
Iterate.
We can iterate, so we can use for each loops in our own classes, right? So this one goes above and beyond some of the stuff we've learned where it's like, oh, let's build an array deck just to understand how an array deck works. If you're building a class and you want to use for each loops in your class, right? So I want to be able to say dog D in dog array, right? Do I have to have my iterator? I can't for each for a dog unless it's an acceptable class. So I do have to do all this, right? To be able to use for each loops. Do we have to have for each loops?
No.
No. Are they really, really helpful? Yeah, they're really helpful. And we're going to use them. You're going to use them a fair amount in project 1C. Okay. So we have. That's a good question. I don't actually know. What do we think? So what's the so a for loop, what's the runtime of a for loop? O of n, what's the runtime of a for each loop? Yeah, I don't think they're going to be particularly dissimilar, right? You just have to go through each piece, right? Because this is what it's doing is that it is using a while loop instead of a for loop, right? And then it's just checking if the thing is there, it's grabbing it, it's printing it.
Yeah.
Right, so it's got O of n runtime as well. Unless you were to put it into some sort of I'm trying to think if you put it into some sort of funky structure, like we saw with our array, with our deck versus our array deck, right? Where, yeah, no, shouldn't. Okay, so again, what I would recommend is that you come back, right? So to get our ugly iteration, we had to do this thing where we created an iterator, right? And this iterator that we created here used the iterator method. So big I, little I. And in doing that, we had to come up and return an iterator. Just happened. Oh, there we go. We had to return an iterator, right? So we have a public iterator. We're returning this iterator. And this is our method. And then we're going to return a new array set iterator. That is a class that implements iterator. I know this is all a lot, right? But we have to implement iterator to be able to return an iterator. And then what are our two methods inside of the array set iterator that we have to make our little I iterator work? Next and has next. So we just implement those two methods by using a position of some sort, right? And doing those two things. That's it. Now we have an iterator. Now, any questions on that? And again, I highly recommend you go in and just erase all this code and try and rewrite it. Okay, or comment it out, put it at the bottom of your screen, and try and rewrite it to see how much of it you can figure out. Okay, that's the best way to really ingrain computer science principles. Because we only have today and Thursday, I'm not going to do that right now. Because again, there's a couple things I want to try and get through. Okay. So if we come down here and we try to do our array set, okay, we're still running into trouble with our for each loop. Okay, we can do our ugly iteration here. This works, but this doesn't. Okay. And maybe, there we go. For each applicable to expression type. Okay, array or java.lang.iterable. And again, if I comment this one out and run that, My ugly iteration should work because we've implemented all the pieces. I just want to make sure it still does. So I didn't erase anything. There we go. This is A. Why is there no second this? Because it's a set. Shouldn't be in there. Right? Cool. But my iteration does not work. This doesn't work. Any guesses on what I need to do? I can come in here and see that I get a funky little error message, which says, for each applicable to expression type, array or java.lang iterable is required. Implement iterable. Guess what? All we have to do is scroll to the top. The problem here is that while I have an iterator method that returns an iterator, and I've got this class that implements iterator, when I go to run the for each loop, the compiler goes and looks at the file, right, at my class, and says, hey, what do you think it's looking for? And guess this is what it's looking for? To run a for each loop? Iterable. It's looking for something that says, hey, I'm promising you that I have an iterator method. Because what do we think the iterable interface, what do we think the method is there? Iterator. So if I go up to the top and I implement, and how do I, so we've never done this before. How do I, can I do more than one implements? Comma, iterable. T. It is a comma. You don't have to put another implements in. Can I extend more than one class? This is sort of minutia in Java language. Can I extend more than one class?
No.
No, you cannot. Can I implement more than one interface? Yes, you can. Now when I run this thing, I've put my for each loop back in. The iterable interface says, hey, I'm guaranteeing that I've got a iterable method in here. And because of that, I now come down here and I now have my for each loops. So I've got the one here that prints it out in a line. This is a this. Oh, wait. Oh, because I didn't, there we go. I just need to put it. Anyone see what I did here? Okay. And then this is A, right? So I've got two different print statements. These are both working now. Okay.
But you select the iterator in the iterable to have it work, right?
Yeah. So if I come in and I'm like, hey, I'm going to get rid of this iterator here. Space here. I'm going to get rid of this iterator right here. Right? Comment that out. I'll come up here and it'll immediately say, hey, class array set must either be declared abstract or implement abstract method iterator in iterable. And I know this is one of those ones where it's like iterator, iterable, comparable, like comparator. Why all the terms are so closely, wrapped up is slightly frustrating, but that's what happens. Return it. I don't ever return an iterator here.
Iterator.
This?
Iterator, yeah. Then override.
I guess, yeah, theoretically it is an override, right? Let's try it and see. Yep. And so here's sort of the fun part here. Where did I put it? Here you go. So this is, you can go into GitHub. Nope. You can go into GitHub. Nope. Oh, here we go. You can go into GitHub and get all of the code for Java. So here is iterable. Okay. And if I scroll down through iterable, we see that it returns an iterator. Right? There we go. This is our interface right here. Iterable, public interface iterable. It has a method iterator. Okay. Then I've got some default things in here. This is the for each loop, the default thing for each loop. And we got a splitterator. Isn't that a great word? We don't have an iterator, we have a splitterator. That's a good question. I've never used one. Yeah, but that's what the interface looks like for iterable. right? So we are actually overriding iterator. Okay. So that is an override in there. Good catch, Tony. Other questions on this? All right, because we got two more things to implement. Let's come back over here to our here. That's iterable. And just so that you sort of understand the way that works, set is, what is set, by the way? What type of thing is set? Set's an interface, right? And then what's an implementation of that interface that we will, the only one we'll probably use? That we built the array set, say again? Hash set. Right, a hash set is a set that implements the interface set. Set is implements collection implements iterable. So iterable is actually above collection. Okay, because you can iterate through other things, but that's sort of the hierarchy of the way this works. We have iterable with our iterator. Collection extends iterable. And obviously, because of that, it has to have an iterator method. Set extends collection. So theoretically, what's the other way we could do this instead of implementing iterator over here? What's the other way we could do this? Oh, sorry, not there. Here, instead of implementing iterable up here. Could we put it over here? If we take iterable out, right? And we implement it here. Jackie, is that going to work? Implement. Change implements iterable to extends iterable. We're going to leave it the way it was. Would we still, oops, if we, let's do that. Take it back. Extends iterable. I'm curious, never tried this. And then this, and then we're getting, this just has set interface. Should still run fine. There we go. Because I got rid of the other ugly iteration. Okay. So the interface is extending the other interface. I didn't really want to go there. So never mind. We're going to leave it where it was. Because that gets a little confusing on the extended versus the implements. Okay. Questions on that piece though? Two more things we have to do. We have to implement a toString and we have to implement our equals. So the two things that we're is going to override, and where do we inherit those from? Our toString and our equals. Where do those come from? Someone other than Jackie. From our object class, right? We inherit our toString and our, I think actually we get a nice little, here we go. So these are object methods, toString, equals, hash code, and then we have a whole bunch that we will never use, some of which aren't used just at all. Get class is actually pretty handy in a way. And then most of the rest of these, so we might use get class. I don't think we'll use any of the rest of these. At some point, we will override hash code, but these are the three things that you virtually always want to override in any class you write. Your toString, your equals, and your hash code. Why our toString, first of all? Yeah, right. Because if I come down here and we don't need our set anymore. But if I come down and I print my computer's being really slow again. If I print out my array, right, I'm currently going to get, come on. I'm currently going to get whatever the hexadecimal code is, right? Array set at hexadecimal code. We don't want that. So you're going to come down here. Typically, we'll do that at the bottom. Public string, actually, let's do it properly. We're gonna put in our add override, public string, toString. What I want to have for output is curly brace, number, comma, number, curly brace. Try to make your toString give us that. Pardon me for a second. There are like 4 different ways to do this.
Like, clone them.
Yep, so you want to have it be a curly brace, commas,
1, 2.
or whatever the numbers are, whatever the elements of the array are. Ready? I'll be more scientific. And 1 and 2, comma. There you go. How's that?
Oh.
We don't want to just randomly print 1 and 2. That would be kind of silly, right? We want to print what's in our array list. So this, what should print is, in this case, for what I have, it should be this, comma, is, comma, a, and curly brace. To start, if you have a comma right here, that's okay. And then we'll put Jackie to the test and see if he remembers a better way of doing this.
We have to use like 40.
Would this be a great place to use our brand new for each loop? It would be a good place to use it. Do you have to? No. Because, well, yes. But it's a great place to use it. Then what? Then the for each loop?
I'm saying, you said there's like a easier way.
There's a handful of different ways to do it. Some of which take more memory than others. Make sure you're testing it, see if it works.
So don't create this. Well, yeah, because they're listening. Oh.
I didn't do most of the.
What's your brain? What is it? No, it's just a signature.
Did you get the video? Did you check the video?
I did.
Yes, it's the same. Yes. When you're typing print, when it's right down here, I think that's the reason it's really longer than two string like that. Yeah, 2 for all the things.
Yeah, don't need a race edit iterator. Race edit iterator just gives us our for each loop. That's definitely not. Definitely not. You just gotta think about printing out, how would you print out those numbers for those strings? How would you include basically different states?
Just think about it. One thing, right? One that's. We can show. Well, if you string inside for this one, that was the number. Use the existing one, which is your. Which not your.
What's the hardest part of this, once you sort of understand the logic?
There are too many null elements.
Too many null elements?
Yeah, if it's like not full.
Okay. If the underlying array isn't full,
Yeah,
okay.
if you wanna use like. for-
So if you want to use a for each loop, so there's one way around that, right? What's the other trick, once you got that piece down? What's the other thing you have to think about?
The format.
Specifically, what part of the format? Okay. What do you have to actually account for? Yeah, the last comma, right? So it's pretty easy to get this with the last comma in there. It's thinking through how to get rid of that last comma. So you're just trying to return the elements in the array set with curly braces at the end. So what's a good place to start here? Just return the elements in the array. Return, right? So we could do something like this. We could say, all right, what do I need to start with? I'm going to return a new string, right? So string return equals, and we'll just do that, right? And then I could theoretically just use a for each loop for what do I want to do here? T item in in what?
Or like whatever the name is.
See, but what do you down here?
AR.
I can't use ARR. I'm not in my main method.
Well, like the class, the instance.
In this, I'm using, this is one of those places where this is actually, right, theoretically, should work. Just print this, right? Or print item. Yeah, that's a good point, right? So that's not what I want to do. I don't want to print it. I want to say return plus equals item. Yeah, so yeah, right. Well, first I just want to do this. So plus item plus, let's just do, sure. Whoops. Plus space with comma. Yeah, and then we'll return. Let's just try that and see. So now this one here. Just want to make sure I get rid of all my other print statements for a moment because I don't want to confuse myself. Now when I run this, it should give me at least the words in a line. Maybe. There, this is great. So I'm halfway there. So this is pretty simple to throw in the first bracket. Where do I put that? The very start. Okay, boom. I don't want to space there. I'm just going to keep running. I'm just going to keep testing it as I go to make sure this thing's working. It's a little slow, and we'll talk about why it's a little slow. Great. And then what do I do down here before I return it?
Back bracket.
Yeah, I could just say return plus equals and just throw in the end of bracket. And I've got this. Right? So that's a good close approximation. Boom, there we go. I don't really want the last space and or comma, but this is close. Right? So what's another way of doing this?
You can do like a substring after the for loop.
And now wait, why were you running into trouble with, because I've got this, why am I not running into the null trouble that you were?
Your size is 3.
My size?
For the list.
If you change that to the instance verifies in the master error.
What do you mean? This is the instance variable. All right, so if I step through this, I've got 16, 15, 16 nulls. All right, this is this gets kicked out. I print it. Oops, I wanted to step into the print. Damn it. Let's try that again. Being very slow today. Okay, visualizer, step, step into. Okay, so here we got string return. It should give me, there we go. We got the curly brace. For item in this, right? The first one is this. It adds it to my print statement, but I'm not going to see. I come back up for item in this. We get is. We add it to return statement. Item in this. We get a. We come back up. Right? What do you? I'm curious what the difference in your code is.
If you like go up to like the instance, like the list of the array set, yeah, like ARR, use ARR instead of like this. So it's a list.
Oh, you used this list. Oh, yeah.
So like the for each will do every single element.
Yeah. So you want to make sure you use this so that you're just getting the elements, so you don't need to worry about your nulls in your full array. Because the other thing is, think about the time complexity. Let's say we got this thing up to some, like we're not resizing properly, and this is 100 items long, and you use array here to iterate through. What's going to happen? It's going to go look at every single null box. Right, so you don't want to look at all the null boxes. You want to just iterate through this. And this is one of those cases. I've been talking about this in AP class. How often do we really, like in AP, how often do you actually have to use this keyword?
Rarely.
Ever? Like, I don't think there's a single case where you actually ever have to use this in the AP.
Sometimes you think structure, but it's like, you don't have to.
Well, if you're writing your own code, right, they make you do it. That's how they test it, right? So yeah, they'll throw in a couple questions of, okay, your instance variable is name and your local variable's name, so you have to use this, right? They do that to you, but in your real code, you don't have to do that. This is a case where this keyword is what you use, right? Which just makes sense. Okay, so this is one way of doing this. Now, who was able to get rid of the second comma, and how do we get rid of that?
Well, you can just do a substring after the for loop, from 0 to length -2, so you can get rid of the comma.
Oh, interesting. So you did, what'd you do?
Return equals to return dot substring
Interesting. Okay, yep, from
0 to dot size, the length size, size.
return dot size -2,
Length or
not size, because return doesn't have a
Length.
length. Yeah, return doesn't have a size. Let's try that. That's an interesting way of doing it. That allows us to keep the for each loop, because typically to be able to do this, you would have to do something else. There you go. Nice. So that's a clever way of doing it. What's the other way of doing it? Donald, do you do this way or do you do a different way?
Yes.
You did the same way? I know Mary did it differently. What's another way of doing this? Not using this return equals substring.
Could you check what algorithms have?
Not inside the for each loop. So what are we reduced to?
How do you count?
What's the simpler way of doing it than adding a count? We'll put Mary on the spot. Mary, I don't think you did it this way, if I remember correctly. So what they did is they used the for each loop and then came down and did a substring and just took off the last two characters. What did you do?
I just did like a for loop, but I went to size -1.
There we go. For loop size -1, so we don't include the last item. Right? And then down here, instead of this, you just go in and add the last item. Right? So if instead of using the for each loop, if I use, I don't want to, yeah. All right, we'll do it. All right, if I do this, I'm going to do it differently though, because I'm going to show you one other way to do this, which is, does anyone remember what the problem with doing this as strings is?
If I
item doesn't have a toString method, it would potentially give you an error.
Okay, well, what else? Memory wise. I talked about it with you all much more recently than I've talked about it with you. How is the string? What happens when I add a character to the string?
Oh,
It it rebuilds the entire string, character by character. Okay. So if this were the entire book, I don't know, of War and Peace, okay, and I went in and I added a curly brace at the end of War and Peace, it is going to rebuild the entire string, okay, each time. So it's super memory intensive. It's not great for longer strings. Do you remember what another alternative is? I'm going to get rid of everything from here up.
String builder.
String builder.
Builder, yeah.
Builder. We're going to do a string builder. And return equals, it is a class, new string builder. Okay. And then we can do something like here, I'll do the for loop for this one. For int I equals 0, I is less than, what do you use, Mary? Size -1, I plus plus. All right, so we're going to go through and we're going to return. You'll see that we can do dot. And what do we think we use for a method? Append. So we're probably going to use append. And we're going to append what?
ARRI.
Okay, ARR at I. Okay. That should, and there you'll see our return statement isn't quite right. That should give me what? That should give me everything up to the last element. So then what do I need to do at the end here? Return.append. Array at size -1. Okay. So we're going to do that. And then you'll see if you come down here and you do, hey, required string, you're providing a string builder, make toString return. So guess what we have to do? This, no, sort of.
Return dot string or dots on
Dot.
val.
You actually add the toString. This is one place where you actually have to call the toString method. Because return is a string builder. To convert it back to a string, you have just called toString. Okay, so now when we do this, I'm still calling my print method on my array. Theoretically, if I haven't screwed this up, which is entirely possible. Oh, and I forgot to put in my curly braces. So I'll have to go back and do that.
And the commas.
This is yeah, so I've got it there. It's just not quite what I want, right? So in here, where did we go? We're going to append this plus a comma and a space. New string builder. Guess what? We're going to just throw my curly brace in here. We're going to append plus a curly brace at the end.
Add the brackets. Oh, you did.
I just did. Yep. So you can actually pass in for the string builder when you're building it. You can pass in an argument that you want to start with. I've added my comma and my space into this append statement. And then at the end here, I've appended that thing. Okay.
This reduces the time complexity if you know, like.
This reduces the both the time and memory complexity a fair amount. So most of the time when you see people building two strings, they will use string builders. Because a string builder essentially is like a string in process. It's like you're building a string, like literally, right? So it doesn't get spit out until it's built. So as you add all these things to it, it doesn't actually create the string until we get down here. Okay, so that's a nice toString right there. Okay, there are other ways to do it. This is, I think, probably the best. Last thing is we need to write a to and equals method. So we're gonna come back up here. We're gonna do it right before this one. We're gonna do an add override. This one's a little funky because we have to think about what we're doing here. Right? Public what equals? What does my equals method look like? Boolean equals. And what am I comparing?
Strings.
Oh, like two array set.
So what do I want to pass into my equals method? Array set?
Array set.
Okay. Other? Okay. We're overriding the equals method. Right? Because we want to be able to write a dot equals method. What does the string dot equals method do?
It would check.
What does it check? It,
They're elements.
Each character.
if the things in there are the same, what does the object dot equals method do? When you inherit dot, because all objects inherit from the object class, they inherit this equals method.
It checks for the.
It's the at, like whatever
Checks for the ASCII. Or
the
like
at, 1, 2, 3. Hexadecimal.
So it's checking what?
Memory?
So what is it actually checking then? What do you think the method is inside of equals equals?
Like the actual, oh, equals, that's the object. Oh, that's the
When
address,
you're in there, sorry, I gave it away. From the object class, equals is equals equals.
the address.
And what did we say that we should not be doing?
Don't
check.
use it for a string or something.
Well, don't use it. We shouldn't ever use equals equals for any class because that's not really what we want. But what we actually get from the object class is equals equals. Is it the same place in memory?
Yeah, hexadecimal.
Right? So I could write two array sets of 3, 4, 5. Should they be equal?
Yeah.
Do we want them to be equal?
Yeah.
Will they be equal?
No.
No, they won't because they're not the same place in memory. So your job is to write an equals method that allows that to be the case. Do we care about order for a set? Nope, we don't. If an array set has 2, 3, and 4, or 4, 3, and 2, they're the same array set. Okay? Now we have one real problem here to start with, which is the add override saying, hey, you can't do that. Pull method equals to set interface. I don't want to do that. Method does not override method from the superclass. More actions. Pull method, pull members up, extract interface, extract superclass. What do we think's wrong? Do we think that in the object class, this thing says public Boolean equals array set other?
Oh,
T still doesn't like it. No, now it's underlining this. Yeah, equals has to be an object. There you go. You remember override your object methods, your equals methods? Okay. Will you help me out and just because we have 7 minutes left, which I don't know. This class in particular runs out of time really fast. Because you're all so excited.
Yeah, like complexity for this be n squared or something?
What's that?
Should that be n squared?
Our equals method?
Yeah.
Well, in the array set, what can we use? Let's think about what we could use in our array set. We should be able to do this in, well, it sort of depends.
Well, because if you access like every element in the first like array, but you try to find if it's in the second array, that would take you n time, and then each element would take it to n.
Yeah, but what do we have in our array set that's going to be really handy? What method do we have in here that's going to be super useful to you? Contains.
but like object doesn't have. The object, like the computer doesn't know if it's like a array or
So what do we have to do first?
half it.
Yeah. So you have to make this object other into an array set, right? Or, right, I could do something like array set equals, how do I cast it? Array set. Other. Now, it's not gonna like this because it's gonna say raw use of parameterized class, right? So we need to sort of think through, we're gonna have to think through some test cases on this one. Other equals does require us to do a little bit more work. Here, you can actually go in and we can get the, again, in GitHub, we can get the equals method right there. So there you go. This public Boolean equals object, return this equals object. That is what you inherit from the object class. Not very functional.
Wait, can you compare like a hash set to your array set though? Do they have to be the same for the class?
So that's a good question. So one of the things that we want to do we want to have it be
I mean,
just a set? Probably, right? And then how do we do that?
you don't really have to do anything, because you already cast it, okay, you have to cast it as a set, not an array set.
So cast this thing as a set. Well, but remember that my array set isn't a set, it's a set interface.
Oh.
So I can't do that either. So for right now, we're just going to cast it as an array set. Okay. So we're going to say, no, we can't compare our array sets to other sets. Could you compare a tree set to a hash set? We should be able to, yeah. Yep. And ultimately, what we do if we were building an array set in this way, we would make it extend the set interface as opposed to the array set interface. There are some tricks to this one. Okay. Can we use a for each loop in here?
Yeah.
Definitely can. This is where a for each loop will come in handy. This, if other so what my 2 cents is, don't try and build a set because it won't do it. So what you're going to do is you're just going to come down here and we can get rid of all this code for right now. And we could just make this an array set. This an array set. And then we're going to add, oops, it's got to be strings. We'll put them in different orders. Is a this, whoops. So that we got that, and then down here we should be able to call print array dot equals set. Right? Did I do that right? Array set. And what should this print out? Should print out true, right? These two things should be true. We do need to address you got a problem with your logic.
If this would work, I was like, what if I made, other than go to a set, because we can't copy duplicates, and like, if the size of it is not the same as your array size, then it's not the same, because it means it has like an extra.
So so first of all, this has to be, the equals has to be an object, and you should use the override. So you gotta do that. There's an easier way to do that. What's the easier way to do it? Instead of going through all that logic. Because you have the right idea. That's something we need to do. So what is it that ultimately you're doing?
I'm like checking line.
Checking length. So let's just do that. Right? So instead of, first thing we need to do that makes our lives really easy is say if if this dot length, this dot size does not equal set dot size, what? Yeah. So I think that's what you're trying to do, right? But that's the simpler way to do it. Check that first, because if they're not the same, they're not the two same lengths, we're done. Right, because they are sets. So that's our first step.
Shouldn't it be like that dot something? Another,
Where here?
yeah,
Um,
oh wait,
no.
no, other than Boston, you're casting it.
Oh, you're right. Sorry. If, yeah, set, you're sorry. Yep, you're right. We're gonna change this all in a second anyway. But here's the logic piece. So Ethan, this is important. If I'm going through and checking my logic for item in this, if set dot contains item, return true. What's wrong with that?
It has one element.
As soon as, yeah, right? So what should I be checking instead? Always try to falsify,
Like that.
right? It's one of the beauties of computer science. It makes you think of falsifiability.
If it
So
doesn't.
if it doesn't contain the thing, right, check this, falsify. So if not, set contains, return false. As soon as I hit something that doesn't line up, I return false. If I get through everything and it's all good, I return true. Now I should be able to come down here, and this print statement down here now should maybe work.
The return true is the for loop, should be out of it.
Oh, did I do that wrong? I did. Let's see, missing return statement. You got it. Return true. Oh, it's still in the for loop. You got it. Good catch.
That's the same code, mine doesn't work.
Yours doesn't work. Good. That's what I was hoping for. Let's see what it's throwing at us. Oh, it works. It's just giving the wrong answer. I got true.
That's false. Did I do wrong? What the?
That's our toString. This is this. So there's one piece of this that we are potentially doing wrong, which is what happens if what if I did this with the set that was a hash set? Oh, we got to go. We're over clock. Sorry, guys. There is some homework in there. So listen up. This is important. I'm sorry to take you over in terms of class, but check in for a second. Eyes up here. There's homework. It is project 1C. Okay. I don't expect you to do all of one project 1C by next class. Okay. Take a look at what it is. You can go ahead and get started by, looking at adding, you need to add, we're adding iterators. Okay. And we are adding our toString and our equals methods. So you may want to start with your toString and your equals methods. Maybe we'll do that. And then we're going to go from there. Okay. So maybe I'll just have you add these two things. You are going to want to add a new piece of this inside your array deck. So make sure that you have a new class or new class inside of your array deck that is max array deck, but you will see the instructions in there. Have an awesome rest of your day. I will see you all later. Yep. Have a great day. Well, I'll see you in half an hour.
Are you available for a trickle?
When? today. Yes, I am.
This one's a rate two on at three, bro. What are you doing, bro?
What, did we figure out the issue?
If you have array and then array two. And then you did like array dot
Oh.
append three two and then array dot append two three again. So I'm like, so yeah.
All right. Let's hold this. Have a great rest of the day. Okay.
Thank you.
Sorry, it wasn't as interactive for you today, but thanks for,
No, it's fine. I enjoyed it.
definitely helps me with you helping out, so.
Yeah, of course. Oh, and also like last week, I was talking about the mass contest stuff.
Mhm.
The other team was,
Oh, yeah, did you figure out what,
yeah, they were actually like, they got disqualified.
they were cheating?
Yeah.
Thanks.
So, yeah, we,
Well, so you won that piece.
right, and then today we just played like the final round
Okay,
for the championship. We
Yep.
got 31 out of 40, our team,
okay,
which is pretty good.
yep.
The other team never really got above 20, so we should be fine.
Oh, wow, okay.
Yeah,
Cool, congratulations.
thanks.
That's awesome.
Just waiting for my results at this point.
Gotcha. And do you get individual results as well, I'm assuming? Or is it just team results? How does that work?
It's like top 5 scores on the team.
Top 5 for your team, you get individual scores or an average of the top 5?
It's the total of the top 5. So there's
Okay,
8
gotcha.
sessions
Yep.
total, and then the top 5, like let's say if everyone gets an 8, that's a 40 for the team.
I gotcha. And you guys got, okay, cool.
Yeah. And also waiting for my college results.
Yeah, you're not alone on that one.
Yeah.
Where did you, remind me, where did you ED?
Oh, E2 Rice.
Okay, awesome.
Actually, I did not go for computer science.
Yep.
I kind of made it like a way around it. Because I know like you can change majors pretty